I'm CK. Tonight we're going to start building a 4x4x4 3D light cube kit from Amazon. Cost $15. It's got some surface mount components and it's got a 3D matrix of the little LEDs. So this is going to be a little more challenging both for soldering and for making sure the grid of LEDs comes out halfway decent. So I'm looking forward to this. It'll be kind of fun. I hope you enjoy it. Let's see what we have in the box. A little bag. Let's get rid of the box. Please contact us for soldering tutorial. I don't think so. Fortunately, your build guide is online. It's linked from the product page on Amazon, so I don't have to give you my email. Thanks anyway. The remote control, a car MP3 player remote control that they've apparently repurposed or got the programming of the LED into this module. Bunch of white LEDs, kind of cloudy white LEDs. They don't look great, but fine. A Lexan base plate, or acrylic or plastic. I don't know what they're made of really. Here's the main board. Music model. I don't know why it says music model, but it does. Some stuff on this side, and on this side looks like we've got, that's where we're going to be doing the major portion of our surface mount. There's a chip that goes on top of that, and the controller and brains of the operation, so that'll be fun. And here is said chip. I guess so. So the main chip, I forget what we call these chip, but it's got the little cutouts for the glue, solder. It doesn't have legs. That's both good and bad. I mean, I kind of like legs because you can glob on the flux and just go to town, drag the solder across it. We'll see how that goes with this. And we've got a couple more LEDs. I think that's the infrared receptor for the control. Let me actually put this in a bin. And we've got another LED, some fine wire, probably a power switch, electrolytic cap, a little speaker. These are in everything nowadays. I've never looked up the price of these. They're probably pretty dang cheap. A couple of more LEDs. I wonder why there are LEDs and then LEDs. I don't know. We'll find out. Some brass standoffs. Another push button switch. Momentary. Screw. A USB, mini USB, or something. I don't know. I never remember what you call particular USB connectors. There's so many of them. It's a standard that has too many things. So I think that goes. Oh, look at that. Oh, okay. It goes right here. And if you'll look, there are pads. There are solder connections here and here. So I think This is only for delivering power. It doesn't do any data transfer because only 2 points are soldered, and that typically means it's just for power. Another white LED. Screws and standoffs, if I can get them all out. And then one more push button. So it seems pretty straightforward in terms of what the board's going to be. The challenge is going to be in creating the matrix of LEDs. Oh, I see. So this, oh gosh, it's awfully complicated. So these are not just white LEDs, these are multicolor LEDs. And this, where'd I put it? This is a grid for assembling the LEDs, putting them in here and then linking them all together, which again is going to be pretty much a pain in the butt. Let me show you on the... So you want to end up, where do you end up? You're building up a matrix like this of all the LEDs, and that's going to be awful fun. That's a lot of soldering and swearing. And we'll work on the main board first, and the first thing we do is put the MCU, which is this. I think it goes like this, but I can't swear to it based on this picture because I mean, oh, I see. I'm sorry, I was confused again. So the IC goes through this central hole, like so, which is interesting because there are solder pads here, which apparently we're not going to be doing anything with. There's 2 capacitors already soldered on the board. So I guess because there's no direct connection there, I'm trying to look at it with it installed, I don't think so. That's the way that's going to go in there. So the first thing we want to do is we want to get the first solder pad at the arrow done, and I'm going to get some locking tweezers. If you don't have tweezers on your workbench, I strongly encourage you to get them. They are really, really handy. Both locking and regular style tweezers. If you go on Amazon, eBay, Mouser, many different sites, you'll find assortments of good quality tweezers. Now, since we're doing this surface mounting stuff, we're also going to be using our tub o' flux. This is chip quick rosin paste flux. There's many types of flux. This was actually made in March 10th of 2021. That's interesting. For most people, a 2-ounce container like this will last a really long time. If you do just a couple of kits and don't do much surface mount, you'll probably never run that out. So the other thing we're going to be doing is, instead of our regular solder, we're going to be using this 0.025 inch diameter with flux inside it, which is somewhat amazing to me, 23 gauge solder. It's very thin and very good for surface mount. I've also switched to what I use as my surface mount tip, even though I usually use it with the legs, and I don't have legs here, but it's got a 30-degree bend in it, and I find that very useful for dragging solder across a surface mount area. So, let me start. I mean, obviously we want to get one position down firmly, and then I hope I'm not getting my head in the shot, but I probably am. I want to get one position down firmly to just lock everything down. So instead of thinking ahead, we're just doing one position. I'm going to rub some flux in there to keep everything from bridging. And that's on. I may have put a little too much solder in there. Let me take a look. No, that's okay. It's not bridged. But I do want to do less solder. The next time I'm going to take the tweezers off now because it's now stuck down on the board. Next I'm going to run flux all the way along here. Okay, now let's go ahead and get solder all the way along here. I think that's good. It's so hard to tell sometimes when if you've got actual conductivity, particularly with these, that you don't really have a leg to notice or to stand on. But I think I'm doing okay here. I'm going to speed up the camera now so you don't have to watch me tediously do each one. If I make a mistake and have to correct it, I'll go back to regular and talk about it. Alright, I think those are all good. I'm going to turn off the cameras for a minute. I'm going to go clean this off with some isopropyl alcohol so I can take a better look at it. After cleaning the excess flux off and then taking a good look at it, all these look good. There are two on this side that are a little suspect. This one and this one. So I'm going to redo those. I mean, I can't really tell you how to do that. That did it well. I can't tell you how to do that. You just got to look and you can see if there's shiny surface from the top of the circuit board all the way through to the edge of the pad. That gives you a really good idea that you've got some. And you can also see gaps. Again, as I look, this one also is a little suspect, because with this board, instead of legs, with the board you can see a little gap if you haven't done it quite right. Now we're all good. I'm going to do a little bit of conductivity testing, make sure the board to the chip is fine. Of course, you got to make sure you get through the rosin flux to the actual metal. They all seem to be conductive from the motherboard to the little daughter board there. I'm going to take a look and see if there's any place I should look for bridging. It doesn't look that way. And let's see, now we're going to put the USB connector on. on this side of the board like that, and then we're going to solder on this side, and this is teeny tiny. Okay, next, because he's telling us to put 4 LEDs on the bottom. That's kind of funny. Power switch goes on now in the same area. I said oops because I realized my top camera wasn't on. I'm sorry. Again, on this power switch, this is the mounting pin, this is the mounting pin, these are the active components. Okay, install bracket for acrylic templates. Okay. I think what they mean is these spacers are going to be used as, these standoffs are going to be used to keep the stand for setting up your grid of LEDs a little bit off your workbench. Step 9. Processing LED pin. 90-degree bend short pin and the 90-degree bend long pin, but they bend in different direction and positions. Here's the picture that I'm talking about. Short pin going that way, that's right, that's wrong, even though I honestly, oh, I see. Let me see if I can get one LED out. So, as you bend it, you're going to bend it with the legs in this orientation. You're not going to be in this orientation and bending. You're going to be in this orientation and bending. And then, same with the long leg. So we'll do all the shorts first, and then all the longs. But it's late here, and this is going to be a lot of tedious work that I want to get absolutely right. So I'm going to stop for the evening and feed the cats. First thing we're going to do this evening is take all these LEDs in this bin, bend the pins the proper way, and put them in this bin. Hopefully I do it right. So, negative lead, cathode, bends. Negative lead goes, bends 90 degrees this way. At least that's what we're going with. I'm sorry, let me put it against a contrasting background. That one goes like that, and then the positive lead, looking at the picture, positive lead is going to go, not put the flush cutters away, got the bendies, and we grip it, it looks like above the natural break that all these have, and I think that's what we want. Makes an L shape effectively, with the short leg with the negative lead pointing that away. So I'm going to put this as my example right here. And I'm going to go through all these billions, excuse me, billions of LEDs. So that's 64 of them bent. And as you can see, they did include quite a few spares, just in case something happens. And as you notice, I didn't bend the spares. Now the next thing is to lay them out on the grid. And that's where we'll tweak our 90-degrees. The short leg goes up. The long leg goes to the side. Because I have them strictly at a 90-degree, I think. Okay, so this is awfully tight. See, we've got the long legs bent a little bit higher. The short legs are bent almost flat with the bottom surface of the LED molding. The long leg you leave about 2 millimeters, maybe 1/8 of an inch up, so they cross but don't touch. And I think what I really want to do, as we learn as we go, is we want to go filling in the grid from the right to the left. And we want to tweak our 90-degree angleness to make sure they all meet. Actually, I just changed my mind again as I think about this. We want to go from the bottom row, then right to left, and then up. I think that's the way this will work best. And tweak our bending as we go. And this is another case where I think I'm going to go back into fast motion, and you can watch me lay it in. Okay, they're all laid out into their grid, and now it's time to start doing soldering. Where's my good, I'm going to use my really thin solder that I used on the surface mount side to do this. And I'm going to start on the left side, and the reason why I'm going to start on the left side is because there's no crossing on this side. I can do all of the short leads in a row here, get things aligned, get things stabilized, because you really want a 90-degree angle between the short leg and the long leg. So okay, so I've done one L, and I'm sure you don't want to see me do every single LED, all 64 of them, with 2 legs each, so hundreds of little solder joints. So I'm going to go ahead and turn the cameras off, because you don't even want to see the fast motion version of me going through this. I'll come back live when I've got all the grids built up. Back live, and I'm on the last row of all the LEDs, all 64 LEDs, and I wanted to come back live to talk about what I've learned as I've put these together. and we'll see them all in a minute. I'm just finishing up this one, as I just said. So the first thing that I learned very quickly was the short leg bend needs to be flat onto the base of the LED. Don't have a little hook. It's got to be flat. The long or positive lead should have about 2 millimeters between the base and the bend. So that is all soldered up. And what I did also, this is just out of, where did this silly things? Just out of a abundance of paranoia, I marked one leg on one of the short legs black and one of the long legs red. Just, you don't need to do that. I just did it because I'm very paranoid. I'm going to bring another thing in here, so I'm going to turn the cameras off for a minute and I'll be back. So I grabbed my guitar repair mat, cushioning mat, out of where I keep that stored, so you can see, have a little more contrast and you can see these better. So if you look, say on this one, you'll see I was too close. I didn't bend the cathode lead down flat, and I was so deep into this. Instead, I just bent the wires up around it. Now, what I've already given these an eyeball, but I'm going to give them another eyeball to see if I can see anywhere where the leads are shorted against each other. What we're going to do is we're going to make sure each of the LEDs lights up. And we're going to do that by using a multimeter in connectivity. See, we just have the positive probe from the meter on the anode, and then just touch all the cathodes and make sure each LED lights up. We could probably go there. This also shows you if anything's shorted. So all those LEDs work. None of the leads are shorted. Do it again on the next one. They all light up and it doesn't look like anything is shorted. So we're getting ready for the next stage. Now we're gonna get ready for final assembly, putting this grid on the baseboard, and we're going to take the short leads, the cathodes, bend them 90 degrees up. And this is a challenge on some of them because some of them are soldered. You got to make sure you don't break the solder joint. And you also don't want them to touch. So, and as you can see, the LED got a little tweaked out of position there. So I'll put it back in position, making sure I'm not too off. I want to be nice, 90 degrees. And again, every time I manipulate it, I'm double checking so I'm not grounding. I think I grounded these. No, I did not. Okay, that's one ready. So what this is going to do, if you're playing at home, want to read ahead, they're going to go into the PCB, and the short leads are going to solder up against each other to make a matrix. Now we take our PCB and we take our LED matrix and we go in the holes marked B, and there's the first one. Now, what does it say? Oh, look at that. You don't have to bend all the pins. Huh. Because I thought all 4 LED matrices tied into each other. However, they don't. It's 2 and 2. Now, as you can see, I'm not soldering anything yet because I want to get an idea of how this all fits together and looks. So what I'm going to do is, instead of soldering the bottom right yet, I'm going to solder one of these leads to get the spacing I want. And measuring what it's like down there, and then up here I want to meet the same distance if I can, which I should be able to. Oops, and then of course as I was pulling the scale away I banged it, which often happens. So I'm going to tack this one set at the top together to get a little stability. Yep, God bless America. That solder took a long time to set up. I'm going to make sure nothing sprung loose here. Oh, that looks good. Okay. So now I'm going to do the other layers. So they're all set up. Now I'm going to, again, unbend my enthusiastic bending. I'm going to solder the bases of these next. So what I'm going to do there, because I want it to be at this height, I'm going to take my locking tweezers. Actually, I'm not. I'm going to be just a little iconoclastic and solder on this side of the board. One leg on one side and one leg on the other side. To maintain the height I want. No, it's not going to come out. Actually, I'm just going to go ahead and solder them all from the top side anyway, the way the board is designed with the through-hole plating and a little rim of a solder pad on the top here. I think this will be just perfect. Next thing we're going to do is put the second set in. Okay, we're going to do the same thing again. So I will fast forward the cameras when you're watching this. Oh, I'm sorry, I'm not going to fast forward right for this second because, well, this stinks. They should have said this. So, the build guide shows you putting in the one by the switch first, the pair of whatever's that goes there, and then you put these ones in, you put the next matrix in to the holes, and you're theoretically gonna put it all the way through like we did the first time. And they're going to automatically be even. However, and again I'm trying to get this in here so I can show you what I'm talking about. See, there's a little problem here. You can't go full depth here because this surface mounty thing is in the way of these holes, which is, quite frankly, annoying as heck. So what I'm going to need to do is get my height right and see how much I have to trim off and trim these legs off at the bottom. So center to center, I got to pull a 1/2 inch off the bottom legs. Well, there you go. And now this last set is full hole, so I don't have to worry about it for that. However, I am going to have to get these positioned right. Okay, I need to hold this somehow, so once again, get our locking tweezers to the rescue, and I'm gonna pin that leg right there to the board. I think that will give me the stability to be able to tweak and twist. I'm gonna run the solder up the leg a further piece than I normally would. Okay, so that's not going to run away from me. Now I can take this one, kind of bend it into that hole. Okay, now straighten that up a little bit. Again, I'm going to give it a visual to see if I can see any shorts. I don't. That's the way it's going to look. We're not done yet. We still have a rather important step to go. But let me trim these leads off. Now the final assembly step is we're going to run wires from these holes up to the cross braces to illuminate the different rows differently. And we've got a bunch of very fine wire. This is single strand, by the way, it's not multi-strand, so that will be a little easier to connect, to wrap around the LED matrix lines. Drop it right there so it actually hangs and stays. Come on, wire. I'm going to solder that down. and we'll solder it onto the circuit board after I've got... Actually, why not I do it right now so I don't confuse myself. I am going to try and make this a little neater. I cut it a little long, so I'll make it a little neater. So you get the idea. So I'm going to speed the cameras through this so you don't have to tediously watch me do every wire. And we're done. Let me see if I can bring this, zoom it in a little bit. You can see the wires going from each individual rank down into this motherboard. Now it's time to turn it on, and I have not cheated. I have not tried to see if it works off camera, so I don't know. Let me turn the overhead light off. Now we're ready to put power to it. And now we're going to turn the power on. Ooh, look at that. It's doing stuff. And all the LEDs are working. Let me aim it around this way. It's doing all kinds of flashy stuff. That's pretty neat. Now, I'm going to lay it down so you can see it that way. Now I'm going to look in the manual and see what else it says we can do with this thing. Once again, it's theoretically supposed to be playing some music through that little speaker, but it doesn't seem to be doing anything music-wise. Ooh. So this button is supposed to affect the music. Oh, there it is. Okay, now we can start engaging the remote control. We can start engaging the remote control. And no, I can't control the volume. That's as loud as it gets. So we can do previous animation. Oops, I have to make sure that infrared sensor can read it. Previous animation, previous animation, previous animation, previous, 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 ooh. And we can do speed up the animation. Slow down the animation. Just play and pause. But it seems to just pause the music. It doesn't seem to pause the animation. And then there's combined animation, which are these three buttons. Ooh. Yep, now it's gone on to happy birthday. We can select animations 1 to 9. There's animation 1, animation 2, animation 3, animation 4, 5. Let me put this at a, tilt this a little bit so you can see the depth of all the LEDs running around. Animation 6, animation 7, 8, and 9. Now, that's what it does. So it does work, and it's kind of fun. And I'm going to turn the music off, because the music is not fun. Now the LEDs are pretty much in alignment, though I'm sure someone more careful than I could have gotten them in perfect alignment, but I'm pretty happy with the way they're set up now. The assembly jig really helps with that, of course, so rely on that. But there we go. It's a little animation box. It's kind of fun. I don't know how much power this draws. I may try it on a battery pack to see if I'm going to do this, if I'm going to put it on battery. But on USB itself, works. USB power itself, 5 volts, works just fine. Again, I don't know how many amps it's drawing right now, milliamps, but it's a fun unit. And I will admit I was a little hesitant, thinking it may not work because it's so fussy to assemble the grid, but it all works. Go out and get yourself one of these. Not for your kids, because they'd get frustrated and throw it against the wall, but for yourself. It's a fun kit. Hope you enjoyed the video.